Welcome back to Ox Tools. I'm Tom. So we got another Meatloaf here. I think it's Meatloaf 31. So wow, that's quite a few of them. We got a whole bunch of packages this week. The mailman's pretty annoyed at me. Some of the packages were pretty heavy, and some of them will be actual lead-ins to further videos also. So there's some interesting stuff that showed up. And let me just say, guys, I really appreciate this. These gifts you guys send out, they're very generous and thoughtful, and I'm still getting used to it, and I do appreciate it. Thank you very much. And so we're going to take a look at some of those things and see that. I bought a couple of things that are of interest to the community a little bit, and I was talking to a friend of mine who is a wire EDM specialist, and anyway, he showed me a couple of little tools, and I've seen them before, but actually he ended up giving them to me, and so we're going to take a look at those. They're very, very high-class tools, and we'll take a look at those. You guys will get a kick out of those. And some flea market stuff. So I went to the flea market and got a few things, and it was the flea market after Mother's Day, so it was pretty chock full of stuff, but I don't know, it seems like slim pickings, or maybe I wasn't in the mood, I don't know, which is hard to believe, right? Anyway, let's take a look at some stuff, and let's get going. Okay, so the first one we have, this comes to us from a viewer. Actually, it's kind of a special viewer. His name is Ryan Maynard, and you guys may remember, I don't know, a few months ago we did a birthday special, and it was kind of a special occasion for Ryan. It was his 30th birthday, I think, and his wife Stacy had contacted me, and so we did kind of a special video for Ryan's 30th birthday. Well, Ryan, a package showed up just kind of out of the blue, and there was some video clips on here which I watched, which are great. Ryan gave me a cool tour of his shop and all his projects that he's working on. He's got a great little shop kind of in the basement of his house, and basement and garage. Got a couple lathes, a couple mills, and some sheet metal equipment, and he works on his motorcycles down there. Anyway, all very cool, and but he also sent me this little guy here, and he made this. I'm gonna pop it open here, and it's an addition to my my hammer collection here, and it's made out of plastic. Anyway, it's very cool and very thoughtful. Thank you very much, Ryan. This is excellent. And so it's made out of acrylic, and I guess right at the end he was cleaning it, and he cleaned it with some solvent, and the solvent attacked it a little bit and crazed the surface a little bit, so it has a kind of an aged patina on it now. Anyway, it's in a little foam thing here. I don't know if he carved out that foam or what, but it fits in there. Anyway, that'll go in the hammer collection. Thank you very much, Ryan. And Ryan, I got to look at your shop down there. It looks pretty good. And take care of that wife of yours. She's a keeper. If she lets you have all that stuff in the basement, and she's got one little corner in there that's hers. So make sure you take care of her. Okay. So. Anyway, thank you very much for the gift, and thanks for the videos. I really enjoyed that, and I appreciate your comments. Okay, thanks. Okay, so this next one here, I got a catalog in the mail, and this came from, it's a photo, B&H Photo sent me this, and this was, I don't know, kind of a flyer, or I don't know what exactly. It came with a package. I ordered some stuff from B&H, but there was a couple of things in here. Let's see if I can find it here. So let me turn this around. This caught my eye here, and you guys will probably recognize that. That certainly looks like a Noga arm, okay? And you know, we've talked about these Noga things talked them to death actually, but they call this the articulating Israeli arm. And now why they call it that, I don't know, but I was intrigued because it certainly looks like a Noga arm, and the price is pretty good. It was 34 bucks. I guess they have two sizes, and it's kind of 1/4 on either end so you can mount a camera to it. So I said, heck, let's just get one. Let's try it. I happen to know that Noga is a company that's in Israel. So I said, hey, what the heck? I'll get one and I'll try it. So get that out of the way. I did, and there it is. Let's take this off. So this is to go on your hot shoe of your camera so you can have a display or something like that. I don't really care about that part. This is what I care about. Now it doesn't say Noga on it. The quality looks pretty good. I have to say that I'm reasonably pleased with or actually I'm very pleased with the quality. It's got pear stone on it, and you know, I don't know who made it, but it seems to be well made, and it locks up real nice, okay, without a bunch of fussing around. And what I plan on using this for is on the lathe. I have an arm, as you guys probably know, to hold the camera, but this will allow me to drop it down a little farther and get some slightly different angle shots on the lathe, and that's the intent with this one. But for you guys out there that are wanting to make your own indicator holder, or you know, maybe the price of a standard Noga is a little much, or you have some of your own ideas how you might want to use one of these, this is a relatively inexpensive option if you wanted to try one out. So this gets 2 thumbs up for price and quality. So I'd say this is cool. Now, caution, you know, it doesn't mount directly to an indicator, so you have to work out a mount for your dial indicator if you want to use one of these for machine work. This is really set up for cameras, but clever machinist types like we are pretty good at adapting these things to, say, a magnet and something to hold an indicator. Okay. Anyway, I just wanted to show that, and once again, that came from B&H Photo. www.bnh.com, and this was like a flyer, and they call it the articulating Israeli arm. Okay, this next one comes all the way. Sorry, I was thinking this one came from a foreign country, but this came from a viewer, actually a local viewer. This is Paul Bollet. And he actually came and visited on the open house and sat around and chatted with all of us. And he sent this little hammer, and we're going to open it up. I haven't opened it up yet. It's got a soft face on it here. Let's get that out of the way there. It's got a nice polish on it. Yeah, I kind of like that handle. So this is a hammer made by a guy named Bill Freitz. Yeah, Bill Fretz, and there's his name right in the thing. And it looks kind of like a goldsmith's hammer to me. Kind of the handle and the size, or maybe it's a silversmith's hammer. I don't know. It's pretty close. Yeah, it's got a plastic face. It looks like it plugs in there, and a set screw. Yeah, this is quite the nice hammer. Anyway, Paul came by and hung out and chatted with all the boys, and anyway, he just sent this as a kind of a thank you. And Paul, this is a very nice gift. Thank you very much. I totally appreciate it. I might have to put this in my machinist box and try it out. Yeah, it's got a high polish on it. You know, when you're doing kind of high class work with a hammer, it's kind of an oxymoron, right? But the hammer actually transfers its pattern to the material. So if I were to tap a soft material with this polished face, the material would actually get polished. as I tapped on it. Now it would have bumps, but the bumps would be shiny. They'd be shiny bumps. So anyway, that is a very, very nice gift. And I appreciate it, and I thank you very much. So, and hopefully you'll come out again next year when we have an open house and visit again. So thank you. Thanks, Paul. Okay, so this next one, this is an interesting piece, and this comes to us from Scott Lundy, and he's in Ojai, California, and I guess Scott's got plenty of time on his hands, so he sent me a little note here. Actually, I'm not going to read the whole note here. It says, made for low pressure, 85 psi max for the hose, using the lathe in the mill with a handy holder made from recycled milk jugs. That's this one here, and this has got a magnet, and I guess the idea is here that you poke that in there and it stays in place. So what it is it's and I tried it out on the compressor, and I'm not gonna plug it in right now. It's a trick custom blowgun, and it's got a little throttle here and a valve up here, and he engraved it. He's got Scott's got a Gorton engraver, so he's real good at engraving. He's got Scott Lundy, Ojai, California, and then he put my name on the back there, and he's got some nice buffing equipment too. So it feels pretty good in the hand. I'd have to say that this is slightly awkward. I'm more used to this kind of an arrangement here, but we'll try it out and see how it goes. And then he sent some other tips here that you can insert. You know, the fine blow and the cheap blow. Anyway, I kind of chose this metal one right out of the gate. Anyway, Scott, thank you very much. Nothing like getting a handmade grip, or excuse me, a handmade gift in the mail. It's just wonderful. We'll got to turn some air on to try this thing out, though. So thank you, my friend. That's a nice gift. Okay, so this next one, if you guys like engines, this next one will be kind of interesting here. And I know a guy, and his name is Rollo Tomasi, and he's a mechanic, and he works on big diesel engines. And we got to talking about wrist pins, piston wrist pins. And the reason we were talking about that is John Mills over at Double Boost was using a wrist pin as a square on his mill. So I said, wow, that's kind of a good idea, right? You can take and I'm going to bring a little one out here. This is a small one. You can use a wrist pin on the mill to use as a square. So the end is square with the side, right? And so Rollo, he sent me a kind of a selection of wrist pins from some different size diesel engines. Now this one here is it's a Ford 6.7 liter, and apparently Ford coats these things with a coating that's similar to it's a diamond-like coating, I guess they call it, DLC, something like that. Anyway, this is kind of, well, this is the smallest one here. So that's kind of a prelude what we're going to look at here. Anyway, so he sent me a selection, and the idea here is that I'm going to check some of these and just see how square they are from the end surface to the cylindrical surface, okay? So that's the Ford 6.7 liter. And then, jumping up in diameter, here's the next one here. And this is, let's see, I thought I wrote on them what they were here. There it is. So this is a Ford 9 liter. That's a 9 liter diesel engine there. And okay, let's get some dimensions here. This one's 34 millimeters, and this one's 47 millimeters by 90 millimeters tall. So we're jumping up pretty quick here. So this is actually proportioned pretty well as a cylindrical square. And once again, we'll probably not in this video, but in another video, we'll check the end surface to the side surface. Now, keep in mind, they're hard on the surface, but they're soft cores. They want them ductile so that they can resist fatigue. So this one in shipping, I think they clunked together, and this raised a little chingus on the side there that we'll have to take care of somehow. But what's interesting is that these are mass produced, so cylindrical squares are not typically mass produced. There's a few of them around, you know, and it's not a high demand item, not like an engine part. So the idea is that, you know, a big wrist pin like this should be relatively cheap to buy, okay? Now, I don't know what any of these cost. He didn't mention any of that. Since it's mass produced, we would expect that it would be relatively cheap. Okay, so let's move up in the world here. So now this is a Ford 12.7 liter, and this has the same diamond-like coating on it. And this one here is 57 millimeters by 80 millimeters. So that's kind of a short fatty there. That's actually once again pretty good proportions. And this is nice and smooth and relatively hard. So I'm kind of encouraged here. So let's take a look at that. Let's move up. Let's move up to the next one here. So this is a Cummins, and this is a 13-liter Cummins engine here. And let's measure this one. It says made in the USA here. This one's 58 millimeters by 90 millimeters. I kind of like the proportions of that. The end surface here is polished or coated also. Only one end surface. So these end surfaces don't appear to be ground. They seem to be turned, and then this is ground and lapped or honed also here. So this is the part they really care about. They want a really good finish here. This is probably not a really important surface. So. Okay, so let's, gosh, I hope all that yapping, I hope you can see those things. Double check the picture. Oh yeah, we're good. Okay, we're good. All right, so, actually, you know what, I'm gonna lay them down. That'll probably be helpful too. Okay, we're gonna lay them down. All right, next one up here. They're getting heavier, I can tell you that. So this is another Cummins engine. I don't remember the size. It says ISX on it. I must have wrote that on there. I don't know. That must be an engine, ISX. This one here, this is kind of a fatty. This one's 68 millimeters by 85 or 86 millimeters. All right. This is a pretty nice looking one here. Now, once again, this one got clonked here. And so it raised a little material up, so we'll have to take care of that to kind of check it. But this has got just a wonderful surface on it here, and it's pretty hard. Okay, so you guys ready for the big guy? I think you are. So this takes two hands. So there's the big Mamaluca. So that is a piston pin, if you can believe it, okay? And this is some kind of earth mover or something. I don't know what. He didn't say what size the engine was with this was, but I think it's just something he had around, and he threw it in the box to scare me, I think. So this guy here, let's measure this one here. This one's about 85 millimeters in diameter, and it's 130 millimeters tall, and it's, I don't know, 12 pounds, 15 pounds, something like that. All right, and then we'll just lay that down kind of as a relative size thing there. Anyway, so those are all wrist pins out of diesel engines. And Rollo, thank you very much for sending these. I appreciate that. You didn't have to do that. I was just asking questions, but he gathered a bunch of stuff up and put it in he put it in a flat rate box. So anyway, you got cheap shipping for all this, which was great. Anyway, so we're going to explore these as cylindrical squares and see what we can do with that. And so that might be some optional projects for you guys out there that might want to experiment with that yourself. Okay, all right. Let's. So we'll inspect them a little bit in a different video. It's going to take a little while to go through them all. Okay, so this next one here comes to us from Southern California, and this came from John Marcus of PTC Instruments down in Los Angeles. And John's company makes all kinds of measuring instruments for measuring durometer and spring forces and things like that. So he makes, his company, I should say, makes instruments for industrial use. So anyway, John, I've had a stream of boxes showing up from John, which is great. I love it. And Adam showed some of these in a recent video when he opened up that box that I welded shut with the chuck in it. So what these are is these bolt down to the mill table, and then you can advance these screws here, and see if I can do it here. Yeah, and it pushes these out. So this acts like a low profile kind of infinite sized vise that you can bolt down to your mill table. So it's funny because I saw those in Adam's video and I go, oh, that's a pretty good idea. I might have to make me a set of those. And so it worked out really good because these showed up in a box the other day, and guess what? I didn't have to make them. That's pretty good. Anyway, John's got a surface grinder, so he's going bananas with the surface grinder here. He ground these all over, and it's got guide pins here, these dowel pins, and to keep the sections kind of moving parallel to one another. So anyway, we'll get those on the mill, and we'll try them out and get some use to them. John, thank you very much. I appreciate it, and you're much too generous, my friend. So thank you very much. Okay, so this next one here, this comes to us all the way from Scotland, and a gentleman named Jim Porter contacted me, and he sent me a scan out of these Zeus Precision. They're just little pocket handbooks, and it's just kind of a quick reference. It's got a lot of stuff on threads and tapping, coordinate calculations for jig boring, for flanges and things like that. And you know, these are meant to slip into your pocket and have kind of handy with you when you're out looking at threads and things like that. I believe. Yeah, it's got Whitworth. So these come from overseas. These come from England here, Coventry. They're made in England. So it's got a lot of English stuff in it. So metric threads, decimal stuff. It's got some inch things in it. Hardness conversions, which are kind of useful. This looks like shaft fits. Yeah, shaft fits. These are shaft fits for different tolerance classes, okay? And it's British standard. Anyway, they're just nice, and they're very nicely laminated. I really like the paper and the lamination. These are pretty good, and this is a great size to, as he puts it, put in the pocket of your boiler suit. And now, if you don't know what a boiler suit is, and I didn't know what a boiler suit is, a boiler suit is a pair of coveralls, okay? Anyway, he sent two. And one of these is going to go to somebody else, and they'll just have to wait. They'll just have to wait and see who that is. So it'll be a surprise. Anyway, Jim, thank you very much. He sent me a nice note here. I'm not going to read the whole thing, but he worked in the oil industry and basically kind of millwright and maintenance type work. And he's retired now, and he likes the YouTube videos, and he's going to put a shop together at some point and do some filming. So we eagerly await, Jim, the day that you get your shop going and shoot some videos. So thank you very much. I really appreciate this. It's a nice gift, and for a book lover. Hey, and you don't need internet access or power to use these, so that's a great thing. Okay, so here's this week's flea market finds. Now there's a couple. I got everything. I figured I'd do this a little differently this time, just for fun. There's a couple of things on here that didn't come from the flea market. These little guys here, and we'll talk about those in a minute, and these boring bars here. So let's just talk about those first, I guess. So these are my boring bars here, and they take a triangular insert here. Well, as you can see, I got a couple boxes of triangular inserts. Well, this is one of my flea market finds for this last Sunday. And these are some, actually they're very nice triangular inserts that have a ground chip breaker in them, which is really nice. Anyway, I don't know, towards the end, this guy had a few boxes of inserts, and I asked him what he wanted. $5 a box, okay? Now, if you've ever bought carbide inserts, you know that that's a screaming deal. So if you have something that a particular size fits, then just pick it up if it's cheap like that. These could be anywhere from $8 to $20 a piece. These are actually circles. And with the chip breaker, those could be $15 each if you had to buy them. Anyway, this guy had them, and so there were some triangular ones, and then there was some just some straight up CNMG 432s. And this is a negative molded insert. These are Mitsubishi, and it's a grade 735, which I'm familiar with. This is an excellent all-around grade. Works good for all kinds of stuff. And this is a super common insert here, and I have a bunch of holders for these. So anyway, so that was $5 a piece for those. And then here's the boring bars that they happen to fit, and I might give those a try and see how they behave in these boring bars here. Okay, all right, so let's set those aside and not chip your nice new inserts there, Mr. Wizard. Okay, so next thing here, found another one of these Stanley 4-ounce, just nice looking ball peen. Now this one's been spray painted with some gold paint, and we'll clean that off. And this face needs to be kind of resurfaced a little bit. But per usual, it's laying on the ground, and I look at this and I just see that well-formed peen end there, and the slender handle. I pick it up. Yes, it's a Stanley, $1. Okay, so once again, I'm not going to leave a nice hammer like that laying on the ground for $1. Okay, we'll clean that up. That'll clean up real nice, and I'll probably show that later on. Okay, now these guys here, I have one of these already, and this is a I don't know, I can't quite read the name on it. It's got a little name on it. These are a little rusty here, but they're basically kind of small space hacksaws, okay? And the way you get the blade out of them is you kind of flex them, and they get pin ends like a coping saw kind of, and you can pop them out. They're actually really kind of nice for small stuff, right? So say not this in particular, but for smaller items, these actually work really good. And or if you got a small space you got to reach in. Anyway, I got a couple of them, and these are $1 a piece with this guy here. And this is one of these abrasive holders here, and this one's actually very nicely tapered down to a fine taper. And this holds your 1-inch or 25 millimeter abrasive cloth, so you can get in there and do stuff with it. Like I said, $1 a piece for those, so that was pretty good. All right, and Okay, so then that brings us, let's see, there was something else with this pile. What the heck was it? I don't even remember now. Huh, okay. I thought there was something else with this pile here. Okay, so this little pile here, I guess was one of the most expensive of my purchases today. This was $8 for this. And these are these little mounted abrasive stones here. And I'm gonna show these coming up here. These actually kind of work good for grinding chip breakers in tools. I've been playing around with those a little bit. And perhaps we can use this as a demo here. But that's a little chip breaker here. And you know, if you don't have a real fine wheel that holds a real tight edge on your bench grinder, putting a little fine chip breaker in like that can actually be pretty tricky. Well, these little guys kind of get right in there and do the job. You can dress that corner pretty sharp, and bzz, bzz, you know, the trick is to not pop over the edge. Anyway, we'll be showing those later on in another one of those chip control videos. Let's see, you wanted a 4 for $1 on those, and then so I said, okay, great, and then I got a handful of other stuff. Here's a little file here, and I can't quite read the damn thing. It's got a safe edge on both sides here, and it's not tapered at all. Maybe it got busted off, huh? I don't know, it's a double cut, it's real fine, and then I don't think I have one quite like this. Maybe I do, I don't know. It says something Swiss on it, but made in USA. It kind of looks Nicholson-like to me, but I don't know for sure. Oh, it's probably a number 4 cut, that might be what it is. You know, getting old as hell. I got these damn reading glasses on here, and I still can't read it, so. And this is a Victor torch tip that fits my torches. It looks brand new to me. It's a number 2, which is a good size. And I don't know, these are $25 or something like that if you go buy one. Whenever I see those and they're in good shape, I buy them. And then the last thing from that, I think $8 for this whole thing. He wanted 10. I said, how about 8? And he said, okay, fine. This little guy here. So this is a kind of a hard material drill here. This is solid carbide, and it's a 1/2 inch diameter, you know, about 13 millimeters, and it's made by Fullerton Tool, and I believe they're in Southern California, and it's got a slight circular grind here, and then it's just got a flat. So these are designed for drilling in really hard materials, not deep holes because they don't do any chip evacuation, but they're hard and the point is really tough. So, you know, like you got to drill a tap or something like that, or I don't know what, or some hard steel. This one's unused. And anyway, so $8 for that whole pile, so that's pretty good. And I don't know, let's see, I got one more thing here, I think. Oh, I bought another t-shirt, this Milwaukee t-shirt, $5. Hey, who doesn't need another t-shirt? Okay. Okay, that was it for the flea market. All right, let's take a look at these guys now. A friend of mine gave me these, and his name's Phil. He's a real nice guy. Phil is a wire EDM specialist. So he specializes in wire EDM work, and he's real good at it. He's been doing it for, I don't know, 1,000 years or something. And, well, he's not that old, but let's take this out here. What this is this is a little tiny V-block. Okay, you can see that. This is a V-block. So this is a V-block. It's made out of 420 stainless, I think. And he wire cut this thing with a wire EDM, you know, and went around this thing and cut the whole profile there with the wire EDM. And then made some small little holder downers that go in there. Anyway, he he gave me this thing, and he said, well, you can have it, but if I need to borrow it back, can I borrow it back? And I said, of course you can. And so anyway, that's a nice little, very small V-block. Now, unfortunately, you can't put this in another V-block very conveniently, so it doesn't behave quite like one of those Wii blocks, the small Wii blocks that go in a V-block. Anyway, that's kind of neat. I thought I'd show that. Now, this is the really spiffy thing here. So, what the hell is that, right? And now this is an invention of Phil's, and it's actually pretty cool. And once you see how it's used, you'll probably want one. What it is it's an edge finder, okay? And so the way it works is you can put that on there, and it's referencing this surface and it's referencing this surface, okay? But so you go, okay, what's the big deal about that, right? Well, in particular, this is for doing angled work, okay? So what you do, let's say we want a hole right here like this that's going at some peculiar angle, right? And it's a very, very precision distance off of this theoretical intersection of those two surfaces, right? And we want to poke down through like that, right? Well, how do you use your edge finders, boys? Doesn't work, right? Well, if you got one of these handy dandy little guys, it does work. So the way it works is you come up, since this is round, you can bump your edge finder against here, right? And this is a known diameter, and it happens to be, that circle happens to be tangent with that surface, and then we're tangent with that surface. So with some very simple trigonometry, you can figure out where that corner is in relation to that, okay? For whatever angle that you happen to be at, okay? So you might have this on a sine bar, and then you touch off so you know the angle, and then you can work your way back to that edge, and now you can move over here and you're dead dog nuts over that spot, okay? Anyway, that's how that works. And this one's just slightly magnetic, which is probably a really good idea. He also makes them with a little pocket in here with a little magnet in there that you snap right on. In fact, that reminds me, he wanted a couple of those magnets, and I have some real thin ones that he would probably like, so I'm going to bring him a couple. So anyway, he gave me one of the, I've been eyeballing these. He's got a bunch of different sizes, and so I've been eyeballing them for a while. He said, oh, well, here's an extra one. I haven't even finished it yet. So it's kind of rough on this side, because what he does is when he cuts them out, he tabs them like that, and then so he can come in here and profile all the way around that, and he actually digs in here, right? And then you just snap that loose, because this is hardened steel, right? You just pop it loose, and you know, he cuts it away most of the way, and then you can just snap it off, and that's the last little bit of the cut. And this is not a functional surface, so it doesn't really matter. So anyway, you get that whole profile in one shot, and then pop it loose, and then, you know, you can lap this on some paper, or put it on the surface grinder or whatever, and knock that down. So anyway, that's a Phil Yano edge finder there. Anyway, thanks, Phil. Appreciate the gift. I really like them both. I'm gonna try to use them. I haven't done anything that small in a while, but you never know, okay? Anyway, I'm going to enjoy those tools. Thank you very much. Okay, so we're over here on the mill now, and these are these big Mama Luca Vice jaws that John Marcus made, and you can kind of see how they work. So they bolt down to the T-slots here, and you can move these around, make it as big as you want. You can clamp something as long as the table. I didn't feel like taking the vise off. And then basically you work these screws in, and you can clamp with it. So anyway, so that's kind of how those work. There's commercial ones that have a fixed end, and then they have a kind of a screw end on the other end. So you could use these kind of like that too. You could just bolt these down and kind of do that too. But I think I like the moving jaw on both sides there. So we're going to try those out next time we got a big block or a plate that we need to put in here. So while I'm here, actually, I think I'm going to peel this off here, because Uncle Stan got his way covers installed on his mill. All right. Oh boy, those actually stuck pretty good. Okay. All right, Stan, you're off the harassment list there, buddy. So that just leaves Uncle Adam over there. So now Adam, he bought one of these. Okay, they were on sale, and he bought one. So we're waiting for him to install them. But he's got a bunch of construction going on in his garage, and he doesn't want to get in there and mess around when that's going on. So anyway, thanks for looking at that. Okay, so here's this Yano edge finder here, and so here's an example here. Maybe we have a block like that, and we want to drill a hole some precise distance from that intersection, from there to there, let's say. Okay, and let's say we're gonna. Let's see, can you see all that? You can't really see me drawing on that. I think this will still be fine. So the way this works is you drop that on like that, and that's mated with that surface, and that comes up against that surface. So this circle, which is 1/4 inch, I think, on this one, about 6.5 millimeters. So that's tangent, and then that inner surface is also tangent with that circle also. So we come up with our edge finder, and we can edge find that and move over the edge, and then with some simple trig we can get over that corner, even if that corner has a little bit of a radius to it. So here it's pretty crisp, so you could kind of eyeball pick it up, okay? But if you really needed to make a precise hole, through here at an angle, then you'd really have to pick up on that edge. Now, so this is, a trickier operation in tool making and die work, is getting a hole in at an angle at a particular distance. For example, maybe you would have 2 holes going in here that had to be very parallel, but it was some angled shape here, for example, and so you had to put a hole over here and you had to put a hole over here, right? Well, to get those centered, you need to pick up some datum there, okay, to work with. And this works, even at high angles like that, okay. I'm still in the frame, yeah. At high angles like that, and then all the way down to 90 degrees, but at 90 degrees we don't really need it. Now this also works for, let me grab something else real quick. And I just grabbed this. It's kind of arbitrary here, but these are not perpendicular. So you can actually work out the math to figure out where that corner is on something that doesn't have a 90-degree corner, okay, which is also kind of a useful thing. Anyway, this is just a kind of a neat little tool, and I thought I'd share that with you guys.